Morning guys, let's start our chemistry session today at the starting chapter of solid state. So you can see the chemistry symbol. There are so many figures, flame, structures, everything you should be familiar by the next year. Okay, let us start our session solid state. So this is a class 1. In this class 1, we are going to deal up to classification of crystalline solids depending upon their constituent particles. So see the structure. So some atoms are vibrating about their fixed positions, but they are not moving out. So you should remember this one, because in later sections we are going to have the use of these vibrations. Let's go to next slide. So depending on the intermolecular forces, matter is of three types. Because what is solid state? If anybody asks, how you are going to tell? A solid state is a matter. Okay, matter is nothing but anything which occupies some space having some mass is called matter. So solid state is one among the matter. So if you go for the fundamental states of matter, how many states are there? 3 states. We are going to restrict it to read up to 3 states only. But if you go beyond it, there are 6 states of matter: gases, liquids, solids, plasma state, Bose-Einstein constants, and some other state is there. I don't remember that one. Okay, let's go. But these 3 are very familiar. Those remaining 3 are they are going to exist under very extreme conditions. The 6th state is quasi-static state. Okay. Remaining 3 needs very extreme conditions of high energy, low temperatures, like that. So about gases, we learned in our first year. About liquids, we have some introduction like what I can say: surface tension, viscosity, their density, evaporation, vapor pressure, etc. Then somehow we are going to read more about liquid state in the second chapter of our 12th class. The states of matter classification, these gases, liquids, their physical properties, you have gone through them in your 9th class itself. So if we come to the solid state, our particular topic is solid state. Now what is solid state? Solid state, the particles are very close together and they are held by very strong intermolecular forces. Again, so these solid particles, in these solids, the particles are very tightly held, closely held, and the particle distance, interparticle distance, is very small, and they are going to have fixed shape. They are rigid. Like that, you are going to define the solids. So let's move. So these are the 3 states of matter: solids, liquids, and gases. So you can observe here, in solids, they are very tightly packed, like a very huge classroom, a 40 capacity classroom is made to sit with 100 people, like that it is. While liquid state, you can move, and when you come to the gaseous state, so the interparticle distance, here the interparticle distance, if you measure, is very very small, very very small. Don't think that there is no interparticle space in solid state. There is a gaps. There are some gaps while atoms are packed in solid state. So this void, this red color one, you can say this is void. That is going to exist always. Then these are the different properties you know very well from the 9th class itself. Next, what we are going to learn here means what is our aim about solid state we are going to learn. We are learning the complete session objectives. We are going to read about solids. We are going to read about classification of solids. We are going to end our session today with the classification of solids. Then structure determination, but it is not in our part of syllabus. Only one formula I have to remember. Then lattices and unit cell. What is lattice? What is unit cell? Packing in metallic crystals. Packing in metallic crystals. What is packing? What are metallic crystals? We are going to learn. Voids. What are voids? Void. void space. Okay? Then packing fraction you are going to learn, and density of solids you are going to learn. So today our discussion is going to end up to classification of solids. So what are physical characteristics of solids? So when you look into the inside of this solid, that is different. How it is going to look from the outside and macroscopic level. Solid have definite shape and volume. That's why we are using solids to make the materials, not air or liquids. Then solids have a regular order of arrangement of particles. When you sit in the classroom, how you are going to sit in the classroom? You are going to sit in a regular pattern like this. Then strong intermolecular forces means in solids the molecules are held together by very strong intermolecular forces. The distance between any two particles in solids is very, very small, and they have low kinetic energy. They have very low kinetic energy. You have seen in the starting slide how the molecules are vibrating about their moon position. If the kinetic energy is high, those particles are going to move away from each other, and the state we are going to call is gaseous state. So when kinetic energy is less for solid state, while intermolecular forces are strong. Then incompressible and rigid. Solids are incompressible, you cannot compress much, and they are very rigid and strong. So let's go for classification of solids. On the basis of nature of arrangement of consistent particles, solids are two types. Means depending on the type of arrangement of particles, we are going to classify solids into two categories. Can you guess what are they? You are eating salt in your home, you are eating sugar in your home, you are using plastics and polythene in your home. So what is the difference between this plastic and that salt and sugar? Can you guess? So if you guess very carefully, plastic is going to break very randomly, but if you throw a big piece of sugar particle, if you break a big piece of salt, it is going to break into a definite shape, into a definite pattern where his parent molecule is having. So those two states are crystalline states and amorphous solid. Crystalline and amorphous solids. What are crystalline solids? A crystalline solid is going to have a definite arrangement of particles, and it is going to have too many small crystals. So many small crystals you can find in a crystalline solid. Okay, and each crystal is going to have a well-defined shape. Each crystal is going to have a well-defined shape and order structure in 3 dimensions. Means each crystal is going to have definite arrangement. You see here, this is smallest base unit is going to be there. Base unit is going to be there in a solid state. So examples are salts, quartz, all types of salts, quartz and quartz glass. You should be very careful. An amorphous solid, and the second category is amorphous solids. Amorphous solids has disordered structure. The atoms are randomly arranged. There is no regular pattern. You cannot find any regular pattern when you move in a horizontal manner and a vertical manner. So it lacks a well-defined arrangement. There is no basic unit to construct this entire solid. Basic unit means the smallest repeating unit with which when you repeat in all the directions, x direction, y direction, z direction, you are going to get the solid. Like in our campus, if you take one classroom, if we expand that classroom in all the directions, we are going to get our classroom buildings. Why our building? Because all classrooms are identical from the external side. So amorphous solids do not have any basic structure. All plastics, whatever you are using, they are amorphous solids. And amorphous silicon, which is used in the photovoltaic cells, that is photochemical cells. Okay. Quartz glass is normal glass. Quartz is a crystalline compound. So quartz means crystalline solid, quartz glass means amorphous solid. Always remember that one. Then let's have some pics of crystalline solids. So these are crystalline solids. See, they have very smooth surfaces. This is quartz, very hard material, pyrite. Okay, this is salt. You can see very smooth surfaces. What about the amorphous solids? See, this small child is eating cotton candy. That cotton candy is one of the example which is preferred from crystalline solid for amorphous solid. Okay, cotton candy. Then difference between amorphous solids and crystalline solids. So far we have seen definite shape, cleavage, heat of fusion, all this you can see. 2 points we have to discuss is melting point, anisotropy, isotropy. What are melting points? If you take plastic, if we supply heat, some part of plastic is going to melt first and some part is going to melt later. But when you do the same thing for sugar, well-defined sugar, it's going to melt at once. Okay, that is called short melting point. Crystalline solids are going to possess a sharp melting point, while amorphous solids do not possess a sharp melting point. So what is anisotropy and isotropy? In crystalline solids, particles are arranged in very regular fashion. Very regular fashion. A smallest unit is going to repeat all over the case. So when you take any crystalline solid, if you move in horizontal position, if you move vertically, if you move diagonally, the number of particles in different directions are different. Ultimately, if you measure any physical property like resistance, thermal conductivity, they are going to be different in different directions. If any physical property measure is different in different directions, those solids are called anisotropic in nature. But in amorphous solids, atoms are randomly distributed more or less. If you move in any direction, the number of particles are going to be same. Therefore, the property, whatever physical property you are measuring, is same in all the directions. So, such type of solids for which the measured physical property is same in all the directions is called isotropic solids. Okay, all right, children. So till now, if you have the summary of it, what we discussed till now is solids, its physical properties, and classification of solids depending on the arrangement of particles, and they are crystalline solids, amorphous solids. Now, what are the properties of crystalline solids? What are the properties of amorphous solids? And what are the examples we learned? So they would ask the objective questions: which of the following is a crystalline solid? Which of the following is a amorphous solid? So you should remember the examples carefully. You should remember the properties very carefully. Okay, guys. Let's move on to the next slide. What you are going to see. So, in our syllabus, we are going to put more effort on crystalline solids rather than amorphous solids. Again, we are going to classify crystalline solids into different categories. So, on what basis you are going to classify crystalline solids into different categories is nature of consistent particles. Depending on the type of particles and the interaction between the particles, we are going to classify crystalline solids into 4 categories: molecular solids, ionic solids, metallic solids, and covalent solids. We are going to read about each one in a predominant manner. So, if we go for molecular solids, the constituent particles are molecules. If you go for ionic solids, the constituent particles are ions. If you go for metallic solids, the constituent particles are metal atoms. If you go for covalent or network solids, the constituent particles are molecules, that is inorganic molecules or inorganic atoms like carbon, silicon dioxide, silicon, what I can say, aluminum nitride, like that you can tell. Okay, let's go further. Next one, what are molecular solids? A molecular solid consists of molecules as constituent particles, and these molecules are held together by very weak intermolecular forces. So, what are molecular solids? The solids which contains molecules as constituent particles, and those molecules are held together by very weak intermolecular forces are called molecular solids. Again, from the chemical bonding, molecules can be polar. What is polar? Molecules can be non-polar. What is this? Polar and non-polar is nothing but if two atoms attached are having some electronegativity difference, then they are said to be polar. Okay, so delta positive, delta negative. More electronegative atom is going to pull the bond pair of electrons towards it, ultimately develops positive charge on the opposite atom, negative charge on the receiver atom. Non-polar means there is no charge separation. So this is non-polar molecule, this is polar molecule. Now what are hydrogen bonded? So molecular solids are classified into non-polar molecular solids, polar molecular solids, and hydrogen bonded solids. In non-polar molecular solids, if we go for them, non-polar molecules are the constituent particles. All homoatomic molecules, nitrogen, oxygen, bromine, iodine, carbon. But carbon solids are going to discuss in network type of solids. Okay, these are all non-polar molecular solids. You can get the doubt. So how H2F2Cl2Br2 are going to become solids? If you lower the temperature, if you increase the pressure, the gas is going to become as liquid, liquid is going to become a solid. Okay, clarified guys? So be careful. Then polar molecular solids, consistent particles are molecular polar molecules, like all heteroatom molecules except BF3. A symmetrical molecule never going to have dipole moment. Here those molecules which are having mu greater than 0, they are going to form polar molecular solids. CH4 comes here, BF3 comes here. Okay, held together by dipole forces are polar covalent bonds. So solid HCl, solid SO2, solid NH3. Hydrogen bonded solids, those molecules which can form hydrogen bonds, they are going to form hydrogen bonded solids. Which hydrogens can participate in hydrogen bonding? See, hydrogen attached to oxygen, hydrogen attached to fluorine, hydrogen attached to nitrogen. Only these hydrogens are capable of forming H bond. Always remember, only this. Okay, so molecular solids are three categories: non-polar molecular solids, polar molecular solids, hydrogen bonded solids. See, what can you expect? What is this? Is carrying with very strong gloves. What is this? What is this? So the question is, what is the type of solid? Is solid CO2. That is a dry ice. Tell me answer when you written. So if we go this one, this is liquid oxygen, blue color. This is ice, just a solid water. This is dry ice, solid CO2. Okay guys, see this solid CO2, very deep freezing options. Ice cream sellers, they are using solid CO2. It is somewhat poisonous. Okay, not good for health. Let's go for ionic solids. The first point you have to get into mind, whenever say ionic solid, the consistent particles are ions. Whenever ions you see, if you say, whenever ions, if you say, the intermolecular forces between two ions is always electrostatic force of attraction. In 10th class, we have read about formation of NaCl, formation of magnesium chloride. Yes or no? So, what are the properties of these ionic solids? Ionic solids are very brittle. Sodium chloride drop on the ground. What is going to happen? It is going to break into pieces. That's called brittleness. Can you melt that sodium chloride on your stove? No, approximately you can. That's not possible. You can change the color of sodium chloride, but you cannot change. You cannot melt it. Okay, these ionic solids are good conductors in their solutions in molten state, because they are going to sodium chloride in water state. If you add water, it is going to split into Na plus and Cl minus. But in sodium chloride solid, if we say, there are no ions. Ions or electrons are necessary to carry the electricity. So that is the reason why these ionic compounds are not conductors in solid state. Okay, these are going to have high heats of fusion. Heats of fusion means melting point. Means heat required to melt 1 mole of substance is called molar heat of fusion. Thermodynamics you learned. These are non-conductors in solid state. So what are the examples? All salts: sodium chloride, potassium nitrate, lithium fluoride, barium sulfate, potassium chloride. Like I can give so many examples. Let's move on to the next one. Metallic solids. What are metallic solids? Consistent particles are metal atoms. So the immediate question we have to get into mind, why we are using metals for wiring in our home? Why not a plastic wire? What makes the difference? Both are having stretching properties. The point of difference is bonding in metallic solids. In metals, the electrons, the valence electrons are going to come outside. Those electrons are going to form a sea of electrons or a cloud of electrons in which metal ions are embedded, in which metal atoms are embedded. Like this, you can see the electrons came outside, are staying outside, in which metal atoms are embedded. So what happens in this sea of electrons? In this sea of electrons, these metal atoms are sitting. So these free electrons can move around. When you supply electricity, what is electricity? Some potential difference, means a different voltage at one end to the other end. That's why electrons are going to flow. So these metal atoms, these electrons present in the metals are going to carry electricity. So what kind of bonding it is? Metallic bonding. Metallic bonding is nothing but a force of attraction between two metal atoms through sea of electrons is called metallic bonding. These metals are soft, these metals are also hard. If we go for mercury, it's a liquid metal, and they are going to have high melting point. They are good conductors of heat and electricity. They are having shiny surfaces, that is slusher. They are malleable and are ductile, means they can be drawn into sheets, they can be drawn into wires, and they have, depending on the nature of metal, the heats of melting points are going to be different. Zinc is going to have low melting point, iron is going to have very high melting point. That's the basic difference you can have. So see, this is a processing of iron in iron industry. Okay, let's move to the next one. Covalent solids. The definition is telling covalent, the consistent particles are held together by strong covalent bonds. These solids, covalent solids, are mainly formed by the non-metallic elements like carbon, okay, and associated ones. Silicon dioxide is a covalent solid. This is going to have sheet-like structures. Okay, carbon is going to exist in the form of, if you go for carbon, it is going to exist in the form of diamond. Carbon is going to exist in the form of graphite. Carbon is going to exist in the form of coal. All these are covalent or network solids. But a diamond is going to have very high melting point, non-conductor of electricity, and high heats of fusion. Actually, covalent solids general properties are they are non-conductors of electricity, high melting point, high boiling point. But the exception is graphite. Graphite is a good conductor of electricity and is very soft and smooth. That's why you should not put pencil leads into the electrical switches and wires. It's going to be very dangerous for you. So be careful regarding it. So what we discussed, guys? We discussed types of solids like crystalline solids and amorphous solids, which are basing on type of arrangement of the particles. And if further, as the part of our syllabus, we classified crystalline solids into different categories, 4 types: molecular solids, ionic solids, metallic solids, and covalent solids. So for each one we discussed the examples, and they are going to ask the questions like that also. Okay, this is our first session for the solid state chart. Okay, thank you. So these are comparison that is made. This table is so much important. I forgot, very important table. So always be careful. Whatever you discussed till now, that is what you placed here. This is nothing new, but it's in tabular form. So be careful. Structure, Black's equation, this is not the part of our syllabus. So we are going to omit this one. Okay, thank you.